Hello guys, hope you guys are doing well. In this topic, we're going to talk about NumPy and I have divided the number into multiple classes so that will be easier for you to understand the complete NumPy topics. In this class, we are going to talk about introduction about NumPy and how to set up NumPy, ND array objects, data types, array attributes, In this tutorial, I will provide the basic and advanced concept of the NumPy. This NumPy tutorial is designed for beginners and professionals. NumPy stands for Numeric Python, which is a Python package for the computation and processing of the multi-dimensional and single-dimensional array elements. Let's talk about what is NumPy. As I told you earlier, NumPy stands for Numeric Python, which is a Python package for the computation and processing of the multi-dimensional and single-dimensional array elements. Travis Oliphant created NumPy package in 2005 by injecting the features of the ancestor model numeric into another model NumArray. It is an extension model of Python which is mostly written in C. It provides various functions which are capable of performing the numeric computations with a high speed. NumPy provides various powerful data structures implementing multi-dimensional arrays and matrices. These data structures are used for the optimal computations regarding arrays and matrices. In this tutorial, I will go through the numeric Python library NumPy. With the revolution of data science, data analysis, libraries like NumPy, SciPy, Pandas, etc. have seen a lot of growth. With a much easier syntax than other programming languages, Python is the first choice language for the data and system. NumPy provides a convenient and efficient way to handle the vast amount of data. NumPy is also very convenient with matrix multiplication and data reshaping. NumPy is first, which makes it reasonable to work with large set of data. Let's talk about advantages of using NumPy for data analysis. NumPy performs array-oriented computing. Second, it efficiently implements the multi-dimensional arrays. It performs scientific computation. It is capable of performing Fourier transform and reshaping the data stored in multi-dimensional arrays. NumPy provides the inbuilt functions for library, algebra, and random number generation. Nowadays, NumPy is combined with SciPy and Matplotlib. It used as the replacement of Matplotlib as Python is more complete and easier programming language than MATLAB. To learn NumPy, you must have the basic knowledge of Python concepts. Alright, let's talk about how to set up Python environment. If you install the Anaconda distribution of Python, NumPy comes pre-installed and no further installation steps are necessary. If you use a version of Python from python.org website or a version of Python that came with your operating system, the Anaconda prompt and Conda or pip can be used to install NumPy. Right. For I'll type the code here so that you can use it. Like pip install NumPy and hit enter, and that will be installed. In my environment, in my setup, the as I am using Anaconda, so in Anaconda NumPy is pre-installed. So I don't have to install it again. Right. Okay. Let's go back and start the fresh. Here is NumPy, and this is feeding and go right. NumPy ND array object. The most important object defined in NumPy is an n-dimensional array. ND array is n-dimensional array type called ND array. It describes the collection of items of the same type. Items in the collection can be accessed using a zero-based index. Every item in an ND array takes the same size of block in the memory. Each element in ND array is an object of data type object called dtype. Any item extracted from ND array object by slicing is represented by a Python object of one of the array scalar type. The diagram on the screen shows a relationship between ND array data type object dtype and array scalar type. You can see on the screen that you have a data type, array scalar, and NG array. An instance of ND array class can be constructed by different array creation routines described in later sections. The basic ND arrays is created using an array function in NumPy. NumPy dot array. Right. It creates an ND array from any object exposing array interface or from any method that returns an array. Right. The constructor takes the parameters. Let's check the ND array parameters. These are the parameters and descriptions. What you are seeing on the screen, what we have is right. Oh, so let's take this small example here. So it's not a big one, but we can talk as a small example to understand. First, what we have to do, we have to import the NumPy as np, right? And a is equal to np dot array, right? In that square bracket, I'll type 1 comma 2 comma 3 comma 4, and at the end I'll write print of A, right? I'll execute the code by pressing shift and enter. So we have executed this code first time NumPy code, so it will take some time to execute it. Let's wait and see the results, sir. There you go. You have the result of 1, 2, 3, 4, and that's what we have printed there. Right. So this is a single dimension. Now let's try a small example for the more than one dimension. Right. Import NumPy as np. A is equal to np dot array, and here I have 1 comma 2 and comma 3 comma 4. Now I'll say print of A. Let's see. So we have more than one dimension output. Right. Let's go back to our level search. All right. NumPy array attributes. In this class, we will discuss the various array attributes of NumPy. The first one, ndArray.shape. This array attribute returns a tuple consisting of array dimensions. It can also be used to resize the arrays. Right. Let's try with an example. And Jupyter notebook. This is nd array.shape. I'll take this as a third example. Now import NumPy as np. A is equal to np dot array and 1 comma 2 comma 3 now comma 4 comma 5 comma 6, and at the end print a dot shape. Here in your previous example we have printed just an A. Here for A we are printing the shape. So so there might be something wrong here. Let's check out what is the error. Module NumPy has no attribute array. So there is a spelling mistake here. You can check it. Array. One R is extra. Now I execute this code. So what do we have? 2 by 3 dimension of the shape. Let's try one more example. Another example is let's resize the shape. Let's see the example. How to resize the shape. Import NumPy as np. A is equal to np dot array of 1 comma 2 comma 3 and I'll take 4 comma 5 comma 6. So I'm taking the values of our previous example. Now I want to reshape that to 3 by 2. What was our previous shape? That is 2 by 3. Now I'm reshaping to 3 by 2. Now print A. Now see, a tuple object is not callable. Tuple object is not callable. import NumPy A NP array 1 2 3 4 5 6. We have A dot shape. We come to, sorry, here I have done the mistake. I have missed the equal to sign. A dot shape is equal to 3 by 2. Now we have changed the shape from 2 by 3 dimension to 3 by 2. Now you can see it here 1 2 3 4 5 6. Right. Now we'll try another example for NumPy. Also, NumPy also provides a reshape function to resize an array. So we have another function called reshape. I am import NumPy as np. A is equal to np dot array 1 comma 2 comma 3 4 comma 5 comma 6. Right. Now b is equal to, we have a dot reshape of, I want 3 by 2. Right. Now print is b. This is another way to reshape it. So the previous example and this example, they both are same. They both produce the same answer, but the way of doing is different. Whichever way you like it, you can do it in that way. Is it clear? Reshape. Now let's move to ND array ndim. This array attribute returns the number of array dimensions. Number of array dimensions. Alright, let's go back to our Jupyter notebook and try the example for ND array and ndim. ND array and ndim. Right. An array of evenly spaced numbers. Import NumPy as np. A is equal to np dot range. I'll take it 20. Print of A. Right. Let's execute this code and see what you have. All numbers till 20. Okay. Let's try one more example and import NumPy as np. A is equal to np dot range 24, and now a dot ndim. A dot ndim. Now, and this is a single dimensional, right? Now we'll reshape this code to 3 dimension. Let's say how it's gonna work. Now I'll reshape it. B is equal to a dot reshape 2 comma 3 comma 2 comma 4 comma 3. I'll take it this way, and here I will print off B. Now I'll execute this code and see what will happen. Here we go. We have 2 by 4 by 3 dimensions. So B is having 3 dimensions here. right? Hope this is clear. Right. Let's move on to next topic. Item size. This array attribute returns the length of each element of array in bytes. Array in bytes. Let's try this in a code. This is NumPy dot item size. Let's go to this code and let's see. First, we'll import NumPy np x is equal to np dot array. Now I'll take 1 comma 2 comma 3 comma 4 comma 5 to type. The type is equal to np dot int 8. Now I'll try to print x dot item size. So what would be the answer we should get? Just guess the size of the item. What is an item? X is an item. So we might get 4 will be the answer. So here n is not defined. I have done a spelling mistake here. It should be np. Let's execute this. We have 1. Alright. I'll remove this 8 and execute the code. And here we have 4. This is item size. We'll try one more example for this item size. We try the type of array is now float 32. 4 bytes, right? Let's see. First we'll import numpy as np. This np you can take anything, ab. So the reason why I'm taking np as numpy, right? That will be easier to understand. Np dot array brackets 1 2 comma 3 comma 4 comma 5 and comma the type is equal to np dot float is, so we have float I'll write 32, float 32. Let's see what will happen. Print of each item contains x dot item size, right? If you get this code, it says d type. Where is the d type? Here is the spelling d, p y p e. It should be p, right? Now each item contains 4, right? So we can take it this way as well. Each item contains 4. This is. Alright guys, is it clear? Item size. Now we move to flags. The not and the array object has these functions. Hmm, let's check with an example. If flag, what is a flag? Now we talk about numpy dot flags, right? Okay. So let's try this example. First we'll import NumPy as np, then x is equal to np dot array of 1 comma 2 comma 3 comma 4 comma 5, and here print of x dot flags. Let's execute this code. What do we have? We have the result of c underscore continuous is equal to true, f continuous is equal to true, and own data is true, writable is true, aligned is true, write back copy is false, updated copy is false. Right, this is the flags. And save this data and hope you guys enjoyed this session. I'm sure you guys understood all the topics which we have covered in this session. If you have any doubts, feel free to email me. I'll get back to you as soon as possible, and try to practice more with different data as an example so that you'll get more concepts. All right, guys, you have fun. So we'll continue the next section with NumPy session 2. Okay, take care. Bye bye.